Alrighty, good morning, ladies and gentlemen. Happy Friday, happy day before Halloween. Hopefully, you're all doing well. Today, I'm going to go into 5.2, which is how we can add and subtract polynomials. So, last class, I introduced this idea of a polynomial. We've actually been working with them before. A perfect example was our linear equations. This is starting to get more complicated and building upon what we know to have more and more complex problems that mirror closer and closer to the real world. So as a reminder, a polynomial was something like 5x squared plus 3x minus 2, where we had a number of terms. So we have 3 terms. That was a terrible 3. And then I talked last class about the degree of each term was the total number of exponents and variables. So if I had, say, like x squared y, the degree of this would be 3, because there's a little 1 here and I add up the 2 and the 1. So for this problem, or for this section, we're going to add polynomials. So what happens if I want to have, say, in this example, they have one polynomial here, which is a binomial, and they're adding together a trinomial to it. Now, last class I introduced this idea of like terms. So a like term was something that we had the same variables to the exact same powers. So for example, x cubed y would be the same as 4x cubed y. But so this is okay, but y x cubed also okay, because I've just rearranged them. But then if I had x y cubed, this was not okay. So because they're two different powers, it needs to match up exactly. The way you can think about this is x squareds represent a certain thing. It represents whatever the value or variable x represents, and then I'm squaring it, so that is one specific number. I want to have the same sets of numbers in order to work with them well. So basically, we can treat this like adding like terms. So same thing as simplifying what we did before, where I gathered up all my like terms. So one of the things I noticed is that there's a negative 2x squared here and a 3x squared here. So these are my like terms. So what might be helpful for me is that those are the two that I'm going to be working with each other. And then I have a negative 2x, and I'll use a different underline. There's no x on its own in the other one, so I'm going to leave it. And then lastly, I'm going to notice that there's a 4 and a 2, so I'm going to draw a different underline. So now I want to add up all the things that have the same underline. So what they've done here is that they've removed all the brackets, and then down in step 3, notice that they've grouped their like terms together. So they've sort of done this. And that gets us to our final answer. So negative 2x squared plus 3x squared gives me just x squared. Negative 2x stays the same. And then negative 4 plus 2 gives me negative 2. So they've split them apart. So I'll show you another example that's not in your notes. So if I had 5x cubed plus 2x squared minus 3x minus 4 plus brackets 4x squared minus 3x plus 7. What I tend to do, I'll use a different colored ink. I like to underline my like terms. So I'll use different style of underlines for each one. So I notice the plus 2x squared, I'm looking for an x squared over in the other one. I'm not seeing any. Minus 3x, I'll do a jagged one. Minus 3x, I'll do a jagged. So I'm looking at the variables, not the numbers. I'm looking at the powers of the variables. And then lastly, I have -4, and I'm also making sure to include the symbol in front as part of this. So how I'm going to split this up, I now have 5x, I'll switch back to black, 5x cubed plus 4, oh, I made a mistake. So one of the things to catch, notice how here I underlined it as a cubed, but it's actually just x squared. So this one's all on its own. So 5x cubed, I'm going to leave by itself. Now I'm going to go and fill in my wiggly line, which I'll make a little bit more wiggly. So I see I have a 2x squared, and then plus 4x. This plus applies to everything, but in this case there's no minus, so it stays as a plus. So then I'm going to go to my jagged lines. I'm going down my powers, and this should be x squared. So then I have minus 3x minus 3x. And then lastly is my loop-to-loop underline that I made. So I have minus 4 and then plus 7. Notice how the plus did not affect this one right here. Because I have a plus and a minus, the minus wins out and it stays as a minus. So then I add up everything that has the same underline. So 5x cubed stays the same. I add the constants out in front, so the coefficients. So 2 plus 4 gives me 6, and then I keep the x squared. Minus 3 minus 3x, or minus 3x minus 3x. The x stays the same, and then I have negative 6x. The way you can think about that is if x represented apples, and someone took away 3 apples, and then another person took away 3 apples, in total there were 6 apples taken away. I'm not changing it to the squared apples. And then lastly, just the number all on its own, so I have -4 plus 7, so this is going to be plus 3. So one of the things I emphasized last class or last lesson was that we went from highest power to lowest power of x. And I stuck with that here. One of the things is that it makes it a little bit easier to gather together your like terms. You don't have to go searching. I know that my x cubes are going to be at the front, so then all I have to do is look at the front and see what the highest powers are and then combine. So the messier your setup is, the harder it is to jump right in. So taking that extra bit of time to organize your thoughts will help you in the long run. This is one way that we can add, and we call this adding horizontally, because I'm just adding it together like I'm doing it in an equation where I'm putting it together and then I'm adding together into the next line. Next one is adding polynomials vertically. I can do the same thing. So they've done the same example here. However, what you need to do differently, it's not like, so it is different from adding I'll call regular numbers. So what I mean by that is if you had 4 plus 17, you would do 4 plus 17, and then you could go through and add them together. In this case, we have to make sure, kind of similar, we have a ones column here, we have a tens column here, we have a hundreds column over here. But because of how we list polynomials, we have to be careful. So what I mean by that is my columns are no longer ones or tens, but if I split down this line for a moment and down this line for a moment, you can see that I have x squares here, I have x's here, and I have no x's. So I'll just say constants. So in this case, our columns are the variable powers. And if it's not included, you have to leave it blank, because technically there is a plus 0x here, but rather than writing that, we just leave it out. So what we want to avoid is writing, so I'll do it quickly and then erase it. I do not want to write 2x squared over here, because that's like putting a 100s into the tens column. So I want to make sure that I'm keeping my like terms in the same columns. And then from here, I can just add vertically with each column. One of the things to keep in mind, so I have -4 plus 2 equals -2, -2 on its own, x on its own is -2x, and then I have -2x squared plus 3x squared is going to give me positive x squared. If I say had x squared plus 7 plus x squared plus 2, or plus, I'll do 4. So say I had this example. So I set up my equation properly, where I have plus 7 plus 4. I've left my x's column empty. One of the things that is also different is in this previous example where I had 17 plus 4, the 4 and the 7 would make 11, and I carry the 1 up, and then this becomes 2. I don't want to carry my 1s here. So when I add these together, I don't have 1x plus 1. Instead, I have plus 11. I still have 0 x's, and I have x squared, and there's 2 of them. So keep that in mind. You don't carry numbers into the next column, because I don't know what x is, and adding 7 and 4 doesn't suddenly make an x appear. So one of the challenges and things that makes us different is you keep them based on like terms. So this final answer would be 2x squared plus 11. Okay, more good news. We're skipping algebra tiles, so I'll just write skip. If you want, this is another way that you can use them to show how we can add stuff together. Because we don't have physical algebra tiles, it's a little bit harder to see, but I will leave that. Next thing that we are going to be doing is subtracting polynomials. So the only difference is now we have a polynomial here, and we have a polynomial here, and now I have a minus sign in between. The important thing for this is the minus sign applies to everything. In the second polynomial. So this minus sign applies here, it applies here, and it applies here. So when I solve this problem, again, underlining can help. So I'm going to start by underlining my x squareds. I'm going to underline my x's. And I'm going to underline my constants. Because at the end, what you'll notice they'll always kind of work towards this is that they will have their like terms together to make it easier to add horizontally. But before that, I need to deal with this negative sign. So this negative sign applies to the negative x squared. So I have a minus sign and I have a minus sign. So negative negative makes a positive. So notice how the change here becomes plus x squared. Step 2, I apply the negative to the positive 2x. The negative and positive makes it negative. So There's that. And then the last one, negative negative 1, becomes plus 1. The trick to this is flip all the signs in the brackets of the second equation, or second polynomial, sorry, when subtracting. The shortcut is the negative becomes a positive, the positives become a negative, and you basically just flip all the signs. So you don't have to worry about each individual one. So long as you see this negative sign here, you can think flip all the signs after it in those brackets. All right, same idea here. I can do the same thing vertically, not a problem. I just have to remember I want to keep my columns the same. So again, I have my constants, I have my x's, and I have my x squareds. And then I remember, so this step here is the flipping the negative signs, or I'll just say flipping signs. So they get 2x squared minus 4x minus 3. The first part doesn't change. And then they get plus x squared minus 2x plus 1. This part here is the same as addition at this point. So we follow it the same route. So I have negative 3 plus 1 gives me negative 2. Minus 4x minus 2x gives me negative 6x. And then 2x squared plus x squared gives me 3x squared. One thing to note, for adding or subtracting polynomials, the exponents do not change. So that's a really important thing to realize, that when I add my like terms, like when I add my 2x squared and my x squared, it changes the coefficient out front, but it is still an x squared. So keep that in mind. Even if I had something like x plus 1 plus x, I'm not adding the powers. This is going to give me 2x plus 1. There's now 2 of whatever x is. If it's, say, like boxes of candy or Halloween costumes, there's now 2 of them. So keep that in mind. I am not ever changing the exponents of my variables when I'm adding and subtracting. I'm just adding the coefficients out front. So adding or subtracting the coefficients only. And the thing is I can do this with any number of things. So one of the practice problems you'll see is that I can have a polynomial plus another polynomial and then minus another polynomial. It is totally valid to see that, and just follow the same rules as adding and subtracting multiple numbers together. We're already doing that here, where we're like doing multiple steps. We're sort of doing 3 separate additions. So tacking more onto the end functions the exact same way. One of the things that you could always do is figure out the answer here, so then you would get your new polynomial minus your other polynomial, and this would go together to give you your answer. All right, so practice. I'm going to say to do every second one with one difference. I want you to do M and O, because O has that 3 variable one. So do every 4th one, except for the last one where I want you to do M and O. 2, you're practicing adding vertically. Again, do every fourth one. And for this one, you can do every fourth one. One of the things I want you to notice is that practice adding horizontally and then practice adding vertically. You'll find one that you prefer to use, but it takes some time to figure that out. So practice with both, see which one works best for you. That's the whole purpose of this practice here. 3, we are skipping, do not touch it, it's algebra tiles. Number 4 is the same thing, except now we are subtracting. So do every fourth one, but also do O. For 5, subtracting vertically, same idea, you are practicing which one you like more. 6 is a big ol' skip because it's algebra tiles. And then our medium questions. 7, you are simplifying the combined operation. So I want you to get this as simple as possible. Do every fourth one. So A, E, I, and M. You are trying to make this as simple as possible, but now the challenge is that they have pluses and minuses and they have multiple things. You can use any method. You can use, they're written horizontally, but you can use vertical if you so choose. All right, this is starting to stay in the medium. So determine the perimeter for each figure. So you're going all the way around. So remember, perimeter is adding all outside edges. And one of the things that'll help you, this one here is definitely a spicy question. If you see lines that are connected, like these, for this kite shape, this line and this line means that this side here is x minus 2. If you see the 2 lines, it means that those two are the same. So use that to help you out. 9, determine the perimeter. So again, you're just going all the way around, except now it's kind of a bunch of weird, like harder shapes. C is another spicy one. So you have to remember that the equation for the perimeter of a circle, we call it the circumference, is equal to 2 pi r. So 2 times pi times the radius. Try E and G. And then lastly, we have our spicy ones. 10a, you were finding the surface area, so now you have to remember the area of each outside face. As a hint for these two, there are 6 faces. For this one, there are 3. So that you have a circle, you have a rectangle, and then you have another circle. And then lastly, the first of its type, I will call this an extra spicy question. This is basically the same problem as above, except there is now a hole on the inside. So you have to find the surface area of this sort of donut shape. So that's all I have for you today. Give this a go. I might, next class on Monday, show you a few of these and go over a couple, but make sure you're good on them because we're going to be jumping into some new stuff. But as always, take care, stay safe, have a good one. Thanks for joining. Bye.